It's okay.
It's going to be amazing.
Yes.
It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
That's so cool.
That's probably enough drinks for tonight.
Oh my goodness. Welcome, all you out in Streamland, and welcome to a late afternoon edition for most of us of the Percona Meetup. I am your host, Matt Yonkovit, the host, and I am once again joined by Marcos and Fernando. Although it seems like in the late afternoon, I have grown a lot of stubble and have 5 o'clock shadow, and Marcos has lost all of his hair. I don't quite understand
Yeah.
how that's going, and he looks very confused, and I can't get over how different he looks, and he looks like he's trying to figure out, but he doesn't quite understand that we're live. What do you think? What do you think, Fernando?
Yeah, I don't know if he's hearing at all.
I don't know
See,
either. It looks
he's
like he
been
might
doing a
not
lot
be.
of Kubernetes lately. Maybe that's it.
Spin up a new pod, Marcos. Spin up a new pod. Oh, now we can't hear him.
Yeah, well, we can't hear you.
Oh, we can't hear you. You're no microphone. Are you muted?
No, I'm not muted. Hello, hello.
Well, it
Now
works
we
now.
hear you.
It
Now we
works.
hear
All
you.
right. Nothing changed.
No, everything changed. Everything changed. Like
Indeed.
you've lost all your hair, and I can't look at you. And like you're so different. Like I don't know what to do.
I'm trying to look like Mark Callaghan.
Oh, is that what this is? Oh,
It's
okay.
closer than it was before, Marcus.
See?
Yes. So before I make fun of you, you're not sick, are you? Like
No. I'm
and
perfectly
you
fine.
lose your hair from sickness. Okay. Then why?
You're invited. What? Well, it's summer and it's hot, and I don't know how to shave and only get my hair out, so I had to do my hair and my beard. So it's gone. Nothing bad. Nothing too bad. Come on.
We'll grow up again. Yeah.
Exactly.
Yeah. I seem to remember, if you're familiar with the Simpsons, Homer Simpson episode when he was younger, had flowing hair, and he goes, "Oh yeah, that'll just grow back." And he ended up
Yeah,
bald.
exactly.
So so I don't know. So you guys are doing some Kubernetes work, I hear.
Yeah, we've been doing 8 hours per day training of Kubernetes. Super useful because one thing is knowing how to use something else is knowing how it works. So we're actually getting into the gritty details of how it actually is built, and the concepts, they become clearer. In all honesty, it's easier when someone with more experience shows you something. So
Yes.
It's even if, again, we've been learning to use it, and we deal with it, and we solve troubleshoot things every week. But in the end, it's not as in depth as we'd like to go. So we're going where we want to be, actually.
Well, who's giving the training?
Oh, it's Laszlo. Oh, what's his last name? County? I can't remember his last name. And it's a Hungarian company.
Very cool.
Yeah, it's friends of Peter Boros. So really good quality. So I'll get you the link to these guys before we end the stream.
Great.
So let me join from my computer. So I have a screen, and we can play. What are we gonna do? Tell me.
Marcos wants to play around. Well, so the official schedule is, I thought that we would start with support cases from hell. Yes. So without naming names, we would love to hear some war stories. I'm sure that there are more than 1 or 2 cases or issues in the past that you've run across that you're like, wow, that was a crazy hard or a crazy, thing that happened. And everybody loves to hear those crazy stories. So I figured we would start this live stream with the support cases from hell.
Sounds good to me. So one, recent streak of support cases from hell had been related to memory allocation, and people precisely running on Kubernetes, very big nodes, perhaps 144, 172 CPU cores. And they create many small instances, and they run many processes. And the thing is, they started experiencing memory out of memory kill on the MySQL process and on MongoDB processes. And well, after lots and lots of investigation, and I'm telling you, Ivo Panovich spent, I don't know, 30 hours, getting to the bottom of it. And it turned out that it was all over the internet in the end. It was not perhaps so hidden, but we needed to actually, confirm it, to actually prove it to the customer. And in the end, this glibc, it will create 8 allocation arenas for each CPU core. And, then it will, if you have 3 bytes in one of those arenas, it will not be allocated. And then it also has a heuristic to preemptively just leave them there. It just doesn't deallocate them because it thinks they're going to be used soon. But when you have 144 CPU cores and you have 8 arenas per CPU core, you just created, I don't know, 1100 or something like that, right? So it turned out to be crazy waste of memory. So you can actually reduce this number of arenas with an environmental variable. And you can also switch to jmalloc. And if you do switch to jmalloc, then you have to disable transparent huge pages or enable an option that I was not aware of and that Sergey told me about it today, is that it's called opt.thp. Because otherwise, you're going to have tons of memory fragmentation, and you're also going to get overwhelmed. So
and that's because each instance has its own little area of memory, and so they don't know about one another, and so you just over allocate each one. Is basically what happened.
Yeah, the allocator created again 1100 plus allocation arenas, and actually as the memory was being needed, it will create more all these arenas, right, up to that number. So it was just able to grow up to that number. That's the thing. It didn't do all of those immediately. But as MySQL is memory hungry, and if you give it memory, it's just going to use it. So it did use it, but then it released it, right? Like large temporary tables for a big union, sorting, stuff like that. And again, we couldn't see a leak in MySQL, and we did investigation through performance schema, memory introspection tables, and we couldn't see also big memory utilization there. All memory was always released. So, in the end, that it turned out to be that those memory arenas, even when MySQL deallocated the memory, the allocator will not release it. So
yeah. that's a tough one.
Very well hidden.
that was nasty. And then I have another one which we are still investigating. We didn't go to the bottom of it, and this is probably one of the things I'm less experienced with, which is networking with border routers. And I imagine there's a border router somewhere in the problem, because they have an on-premises very heavily secured site, and then they have AWS instances, EC2 instances, and we can send packets. We can send packets up to 8 kilobytes, but it's a number that is not even a power of 2.
So wait, it sends 8 kilobytes, then shuts off?
No, it sends 8 kilobytes, but it will not send 8.1 kilobytes.
Right. So yeah, after 8 kilobytes, it just cuts.
Yeah. And,
does it get a partial packet or anything?
No, we didn't got the TCP dump yet, because I can tell you it's a government agency. and things are rather slow, and you gotta be patient and deal with their way of doing things. So they have a team that will take the TCP dump, so they open the ticket with them. So that's not the hell. The hell is networking and not being able to put your hands on the keyboard where the problem is happening. But yeah, it's like I recall a similar case for a company that does fitness gear, and they had a large chunk of servers in China behind the Great Firewall, and they had similar issue, but that was the firewall changing NTU, and then by changing the NTU, they were breaking basically communications. When you exceeded something, they will break down the packet, and then it will not rebuild it on the other side. So, or it will filter out some pieces of the whole packet. So anyway, that's something under investigation yet. But yeah, like those cases are quite elusive because again, you don't have access to all the equipment, right? There are routers and other equipment that is not even a computer running MySQL. It's pure networking gear, and we don't have access. So that makes it hard.
So just before I ask Nando about his interesting cases here, I want to point out for the folks who are still joining that we've kind of doubled the number of people who are online. Yes, this is Marcos. You are on the right stream. He just looks way differently, and it will take you a while to get used to. So just wanted to clarify that. So Nando, what about you? Any interesting or challenging support cases that you can kind of share with us that are interesting?
Matt, one thing that is very nice and challenging at Percona is that you got a bunch of different and challenging tickets every day, right, with different support cases. I think to me, what really kinds of it's most difficult part yet is when there is a bug in the middle and you need to chase that bug, right? And you need to, for instance, there's a server crashing, and with MySQL we have that happening in some situations. And until you get the why this is happening, it takes time, right? So you need to work with the customer to produce a core dump, and then you need to get the right libraries to be able to resolve the core dump, and then you look at the source code to see what is actually doing. And this is, to me, is a skill I'm still developing. I'm quite a junior yet, and so those are the most challenging to me, right? Yeah, in general.
Yeah. So I think that that those are always the more difficult ones, because it's hard to reproduce them, and it's really difficult to narrow them down. So I can understand why those can definitely be a challenge.
Yeah.
So,
and we have another one, which is this guy that he has Proxy SQL, and he wants to set WSRep sync wait for one of his sessions. And he sends the set sync wait, and the proxy is not forwarding to the backend servers, and we cannot reproduce. Like, we have the exact same configuration he has, and we cannot reproduce. And we've been trying to chase that, and Nando was actually talking about that, right? It's like we took a core dump, and now we are going to use the core dump to as support for code analysis. So we're not going to solve it through the core dump, but rather use it as support to get context for doing proper code analysis. So
yeah, reproducing is the thing, right? Being able to reproduce.
And then one hard thing is now sometimes we have tools that will allow us to do magic, right, or do really cool data collection or stuff like that. One is RR project. And,
oh yes, yeah.
And but I haven't found a single customer that told me, yeah, I can send you that. Like everybody will tell me, oh no, that contains sensitive data, I cannot send you that, right? It's like, all right, I tried.
Well,
So,
I do feel bad because we right now, while everyone's pushing to make things easier, we're making things easier at the expense of complicating the crap out of a lot of our applications and our infrastructure, right? There's so many individual components now, and there's so many ways to slow things down, to expose data, to do all kinds of crazy stuff. And it goes so far outside the database in a lot of cases, right? It's not just that database layer anymore. I mean, and so Marcos, you're pointing at me because he has a story that he's thinking about. I can see.
yeah, these guys, they were doing set, but these guys were some other company, right? They were doing set 7,000 times per second. And I told them, like, this is killing you. And they were like, no, how could it be, right? It's like, well, it's not only the set, it's also the network round trip and the SSL encryption for the network traffic and the thread handling and the authentication and, everything. So, and then we did a flame graph, right? For only that thread and where they were sending the set commands. And indeed, right, like the handling of the com set, the command for the set inside MySQL, it took, 9% of all the time. The rest, the 90% was like all overhead from getting to the server to actually send the query. And that's the kind of thing that it's hard to see at first, right? It's like, it's not there. You think it's the server, you think it's MySQL. Michael, no, if there is a workaround, WS rep sync weight is set. We requested a feature some time ago, Vadim or Marco Tusa. I don't know who filed the feature request, but how you can actually set session variables through the query in a comment in the query. Well, unfortunately, WS rep sync weight cannot be set through a comment, but we actually want to do it because that would be perfect, right? It's like, I want this one query to be synchronous. And then you will always...
over Proxy SQL.
Say that again?
No, this is over Proxy SQL, right?
No. I think he was
this particular
just asking if there is a way
in general.
to you will always have WS rep sync weight, because if you don't do the set session before, then you have to send those 7,000 set WS rep sync weight. So what we want to do is just send it inside the query. So while you're parsing the query, it will be set, and then it will only take that 9% of the time. It will be that 9% overhead, and all the other overhead will be shared with the actual query. So it's a big gain.
So with that, I'm going to go back to take a step back from the WS rep sync for a second and go back to where we were talking about, the complexity. And you mentioned like the set, 10,000 times a second. And that will bring me to my first Stump the Expert of the day. Yes, indeedy, I have a graph to show you, and I want you to help me understand what we're seeing. Okay. This is a screen grab, or actually it's PMM, and I will show you the events that were happening earlier today as I was doing some testing. All right, so let's go ahead and make this bigger so you can see this. So hopefully everybody can see. The big thing that I want to show you is the queries per second, and this is Scrub. Now, I want to point out something, okay? For those who are doing benchmarks and for those who are testing performance, there are multiple ways to measure either throughput or queries per second or transactions per second. Depending on how you measure it, you will see vastly different numbers. Now, I have up at the top, these two are both showing queries per second. One of them is scrubbed, the other one is not. Now, I'll get to that in a second, but they are both the exact same workloads at the exact same times. but you look at the two queries and you have two vastly different, outcomes, right? Like each one of these is the exact same workload run 4 times with one change. Okay. And so that one change, you can see on the left side where it says scrubbed, it looks like the last 2 are much faster and better, whereas the right side looks like the last 2 are worse. Right? So interesting to point out, but I'll get to that in a second. So same workload, exact same workload on each one of these, exact same number of threads, exact same data, exact same system. What do you think is the difference between 1, 2, and 3? 1, 2, 3, and 4. Any guesses?
On the scrubbed one?
Yes.
Well, it could be buffer pool warm-up.
But it's too continuous for each
Yeah.
time, right?
Could be. So you changed something. You told me you changed something.
Yes, I actually changed. There's 2 things. So I'll even give you this clue. This first bump here. So bump 1 and bump 2. This is one change. Okay, and then that same change with an additional change is bump 3 and 4. Okay.
Okay.
So whatever I changed to make this go up, I left it, and then I tested it again with the something.
Can I get another? I need one more clue. Is this read workload, write workload? Or
it is a mixed
80/20, 60/40.
It's going to be 60/40, and I'm going to tell you, I didn't change anything inside the database.
Anything inside the database. So better IO scheduler?
No.
No.
So you'll never get this one. So I will give it to you. Are you going to give up, or do you want to guess? You want to guess?
Analysis?
You want to guess?
Can I do that?
Yeah, you can if you want to look at it at the analysis if you want.
Let me try that. Come on. Where do I have my PMN?
Michael Colburn says he thinks it's a var chart. And no, Michael, this is not something that you have seen. So he's assuming that I'm just recycling things I've already shown people. But no, I am not doing that. Okay, I am.
When you say there is no change in the database, you mean you didn't change anything in the MySQL configuration?
I changed nothing in the MySQL configuration. And keep this in mind. If you look at the numbers, okay, so the numbers here, so it is going from 2.9 thousand so 2,900 queries a second to 4.4.
The number of clients.
No, the number of clients is exactly the same.
You change it. Networking buffers.
No. Do you give up yet?
No. I still have like 100 more things I can tell you.
Oh, okay. But we don't have 100 more days worth of time to give you guesses. Okay. This first bump is actually running Python 3.10, and the second bump is Python 3.9.
There you go.
Okay.
No, the newest version actually has a regression, a massive regression in the MySQL connector. And so it's a huge difference. And the reason why this is so interesting is when you see a performance degradation like this, that's probably one of the last things that you would actually check is like who changes or updates their application packages, and it impacts the database. Exact same code base, completely repeatable.
In fact, this is one of the questions we usually ask, Matt. Something changed, so you didn't touch the database. Was there any recent upgrades in the application, drivers, etc.? Drivers are not as often as one might imagine, but they are sometimes the culprit behind problems of performance like this.
And this isn't even a driver issue, though. This is
this is the language itself, the version.
Yeah, it's an upgrade. It's an upgrade from 3.97 to 3.10, and it was that large of a drop off. I mean, that's a pretty substantial drop off. Now, with that, staking on 397, I moved from the MySQL connector over to the MySQL client connector, so a different driver for Python. And so that's what these second two bumps are. Now, what you'll notice is there is no regression between 3.9 and 3.10. So this is 3.10 and this is 3.9. Almost exact uniform performance between the two. So the driver in this case, with the combination of Python 3.10, caused the issue.
Yeah.
And the other interesting thing is, with people who are tuning in, and when you're talking about hey, what driver are you using, most people don't think about that. But even here, you're talking a difference between 4,300, 4,200 queries a second to 48, 4,900 just in changing the driver. And that's partially because MySQL is built on libc. So it's built on the MySQL C driver as opposed to the pure Python MySQL connector.
Okay. Well, I was going to ask you if it was like a native implementation. Yeah. Okay.
Yeah. So now, Marcos, now you said that the set command was run 10,000 times. Now, one of the things that I noticed in looking at this workload, and let me go ahead and I'm going to pull one of these queries from earlier today. So let's go back about 6 hours. And let me show you some of these tests. And so you'll see that there is quite a few queries going on here. You'll see the commit. So there's obviously a ton of commits in this. But one of the things that I also noticed is the MySQL connector does a ping every time you run a query. So it executes, to verify the connection. Whereas the Python MySQL client, which is built on MySQL DB's driver, does not. So you actually see like the numbers here, like the difference.
Must be
So when so I have this scrubbed versus not scrubbed. So you look at the queries per second here, right? So you see these two, which obviously this is the same number as this. The difference is actually just the ping command. That's why there's so many queries per second. So if you look at like queries per second, you're like, oh yeah, Python 3.10 is really kicking butt here with that MySQL connector driver. But it just happens to be that all of your time and the response time, because if you look down here, look at the response time. Oh, look, it's so much faster for this. You're measuring the response time of the ping command.
Yeah.
Right. Yeah. And so here you can see here like this white line, that's the MySQL ping, right? And so versus the select. So I mean it's crazy how much it does it. Yeah, here it is right here. So here's the ping command. It has been executed during this time window, and keep in mind this time window is about an hour and a half, hour and 15 minutes. So what is that? That is 1 billion times. Yeah, so it's been executed 1 billion times. You can't see it, but it's on there.
We always warn customers about empty queries. It's like, the fastest.
But it's default to the driver, and you can't turn it off.
Yeah. In that case, change the driver. Because.
Yes.
Yeah, that's the thing of running in production at scale, right? What doesn't even make a difference when you are testing it, even on staging. When you put it on production and the scale just goes high up, and it will be noticed.
Yes. So the second thing that I have, and let me go ahead and I have.
I recall an article of yours. You had one about Ruby like 12 years ago, probably. But
went on Rails. I probably I probably had one on that. I'm gonna write on this as well. I mean, this is a really compelling thing, and I've been running these tests, and I've been noticing that even like workload changes. So the actual MySQL connector actually performs better in some workloads with 3.10 than 3.9 on a normal workload. So it's very workload dependent.
That's right.
and it's a really difficult one to capture, and we're going to actually get into that in a second, because part of my I don't know what the hell is going on question to you guys, and part of the Stump the Expert, I'm stumped right now, is I'll show you. I've got so I built this benchmark tool to do to basically run workload on multiple systems, and I use the controller to do that and stuff. But one of the benefits of this is you can run workload in parallel across multiple systems and duplicate that workload, in different areas. Okay, and so this is a mixed workload with all the different types of workload that I have, and it's running on an EC2 8.0 instance and an Aurora 8.0 instance. Okay. And I have the config diffs, and there really isn't a lot of config diffs. And I actually backed up the MySQL 8 EC2. I did a MySQL dump of everything and reloaded it into Aurora. So they are equivalent. They've got everything the same. They have the same class of box. Actually, the Aurora one has more memory. It has twice the memory. But you can see here, this is the queries per second right now. 563 queries per second on the EC2 instance versus 77 on the Aurora instance.
Just select.
No, it's a mixed bag of everything. And so, I mean, I can go back. Let me go back. I've been running this all afternoon in preparation for this. And so you can actually see the dips here, right? And so these dips are probably going to correspond to flushing, is what I'm guessing. It's probably, a fairly, decent thing. So over this 3 hours, the average has been 738 queries a second with EC2 and 135 with Aurora. And what's really weird is if I change the workload, I can have these be equivalent. So like if I run just, a very standard, read-only workload or a very write-heavy workload, the write-heavy workload actually performs better in Aurora than it does in MySQL or on EC2. Yeah. And I mean, part of that is, they've turned off the double write buffer, done a few other things. But it's a really weird setup because, like 738 versus 135, that's a drastic difference.
Okay.
And
so there's one thing, right? What is the right way to approach this is if you have less queries, it means some queries have higher latency, right?
Yes.
So what we need to find is what queries have the highest latency, and then try to see what explanation we can find in Aurora that makes that query slower.
If you can find it.
Let's go to query analytics.
So would you like to drive, Marcos? Because you have access to this if you want. I'll let you drive if you want to. If you want me to, I can.
Let me get there, and just 1 second. It's erroring out in all colors to me. No elements.
Yeah, and what's interesting, keep in mind, the exact same queries are run on both boxes with the exact same number of threads with the exact same data set. Now, the data set does get drift over time because it does add things and remove things, but it adds things and removes things and updates things on a consistent basis across all of them. It's just, it fills in like a random comment. So I can't guarantee the random comment won't be the same on both. But even when the data was exactly the same, this difference still existed. And I do know that there are missing indexes and that there are things that could be optimized for both of these. They are both kind of in let's say, a craptastic state on purpose. So we can fix them if we want and see what the difference is. But the fact that the craptastic state is so much worse on Aurora versus MySQL perplexes me.
But the buffer pool or configuration is mostly the same, right?
Again, there is more memory on Aurora. And just so you guys are aware, if you are really, really curious, which maybe you are, maybe you're not, I don't know. Let's see. Can I move this over here? No, I gotta move this whole thing over. All right. So this is the diff PT config diff between Aurora and the EC2 box. Okay.
Oh, the adaptive hash index.
Number of buffer pool instances is double on DC2 as well.
No, but
Yep.
the adaptive hash index.
The adaptive hash index, AHI is enabled on the MySQL DC2.
You told me that write workloads were better, but that your read workload was killing you. And if you have range scans because you don't have indexes, that will make your adaptive hash index super useful, and it will give you quite an edge. I'm not sure if it accounts for like 4x the QPS, but
so I wonder why they have that off by default.
I don't recall if you can actually enable it,
Actually, I'm looking, and I don't even see it in the parameter list.
Well, but it has a smaller buffer pool.
No,
No.
That's 20 gigs versus 8.
Versus 8. Okay.
Yeah. So it's smaller on the EC2.
And also has disabled change buffering, right? And
yeah, but I mean, so adaptive hash index not available on Aurora, it looks like. I can't find it in the parameter list. It's something that I can change.
Change buffering, it's also gone.
Let me see.
And
yeah. They don't. It doesn't look like they have it.
Disabled change buffering will also have impact because as you have to update more pages in the tree every time you write, the commits are going to have a lot of latency, and also there's going to be more locking on the tree, and that some of that locking is actually slowing down the reads. So
several small things that might compute for a big difference as well, right? The number of purge threads, it's just 1 on Aurora and it's 4 on DC2 instance.
They don't have that's an advantage.
Well, yeah. Read IO threads as well, it's double on DC2. What else?
But I mean, 7 times? You think any of those could be 7 times?
Again, adaptive
alone
has a noticeable difference for particular read workloads.
Yeah,
because you're changing between traversing the B tree every time to just going through the hash, right? Like, which is constant access speed versus logarithmic access speed.
Yeah, and a lot of these are range scans without indexes right now because, like I said, it's kind of a craptastic thing. I know that I purposely broke some things.
No, then without indexes, no, because or will it make the primary key also a hash? I'm unsure of that. I know the adaptive hash index will for certain make secondary indexes a hash, but I'm not sure it will do it for the primary key. I believe it must do it because why not?
No, I mean it's possible. I don't know. I don't know.
I need to check.
But no, that's it. That's the list, right? I mean, there's a few things you could tweak. Obviously, there's some things like that aren't untweakable. You just have to accept what they are. It's really interesting because my first test with Aurora 8, just so you
also you have
which one?
Thread handling. You have thread pools and versus 1 thread per connection.
Oh, that could be a huge one because I'm spinning up about 25 connections, like active, like hardcore hitting the system. I mean, that's I guess that's a
Perhaps with
possibility.
exact number, if you match the number of CPU cores of the instances.
Maybe. Yeah, maybe.
Yeah. You know what's hard, and I want to ask Alexander Rubin, because he's now I think he's still at RDS, and I wanted to ask him if they could make available flame graphs, as part of the CloudWatch, flame graph for your instance in CloudWatch, because that's something we mean so much, right? Like that's a very useful tool, and one that again, like we use with great success on a weekly basis, right? That and backtraces, poor man profiler. Those are tools we truly need many times to do advanced performance diagnostic like this, and that it's not possible to do in RD. So I think I will reach out to him and check if he'd be willing to push for that inside RDS, because that will make it so much more friendly. On the other hand, I'm not sure what I would do with RDS and Aurora, because I don't have the source code, because they are not open source. So, like I will not be able to tell by the name, you many times can infer things, but it's not the same as looking at the source code, right?
Yeah. No, I understand. But anyway, so so there are some potential things there. It's just, right now, if you look at the last iteration, it's 1,000 versus 75. I mean, that's a massive difference. It's just, there's something that's there that's with this specific workload, and I can change the workload now, and you'll watch it like adjust. Like I know that if I drop a couple of the threads, the workload just soars. So there's things that are blocking, and it's preventing things from getting through.
Well, the query that is killing you is a select, right? And
here, you want to share your screen, and I'll.
Yeah, why not? Let me try that. Where do you share the screen with this thing?
The little laptop, thingy.
Yeah. Oh, he wants me to apply your updated settings. Reload. If I reload, it will. Oh, I find the code. Yeah, now the place. Screen. No, it doesn't.
So it should request it. Oh, yeah, it should.
Here.
It doesn't.
Found it. Shit. So, do you see my screen?
Oh, hold on a second. It just came up. There we go. I'm going to get rid of. I hope I can get rid of Marcos 2. Yeah, there you go. So I got rid of Marcos 2.
We deal with this personality disturb from Marcos on a daily basis.
Yeah.
Multiple Marcos.
So I took the same time range you took last 3 hours. I selected the Aurora cluster here. I filtered it down here.
Yep.
I assume, I didn't bother it by filtering by schema, because 97% is on that movie's JSON. And then I sort by query time. And, I look at around 1 bit, and this guy took 3.08% of the load out of 61 total. So, I would go to that one first. Explain. What is this? Is this going to explain us? So, it's actually an index scan.
Yeah. So to tell you, the table structure here, there is I don't believe there's a index on year. I believe it's only on the rating index, or on the IMDb rating. So if you look at the query itself, it's ordered by
rating.
Yeah, it's ordered by the IMDb rating. It's the select is on for a specific year, and year is not part of that index. So it would probably be more efficient to have a year and IMDb rating index. So let me go ahead and let me add that real quick.
Yeah, I could not immediately explain why. I mean, it's reading a lot of rows. Let me see. Well, it's not reading so many. 50?
Yeah.
Yeah,
real?
it's limited to 50. Yeah, it's limited to 50. I'm gonna go ahead and add that index now. So alter table. Let's see. And I'll do it on both instances, so that way we keep them consistent. And I'll go ahead and add it on year and IMDb rating, so that should take care of the sort as well, right?
Yeah.
Okay. And it's probably going to lock stuff up because that system is pegged to the max, because that's how we roll here.
And yeah, it was certainly selects. Now, to explain why they are costing you so much,
what's weird is like the other instance has it, right? The other instance still has that same query, and it's still doing the exact same.
Right, but that's what I'm telling you. It's like to actually explain why the selects became so costly here, I will need to do a flame graph, to actually see where CPU time is going.
Oh, okay. Yes, which is problematic with the data that we have.
Oh no.
What was that?
If this has a subquery, but no, it does not.
Yeah, it's a very straightforward query. It's not like it's like crazy, right? It's a pretty straightforward, pretty straightforward setup.
You need to uptune your max user connections for the PMM user, apparently.
Oh, are we getting PMM user error?
Yeah. I wanted to ask you, Matt, how many cores do the instances have?
4 each. So they're 4 core. One is 16 gigs. One is 32. Yeah, they're N5s, I believe. Extra larges, I think. Okay, so those things are running, but it's taking an insane amount of time because the systems are so busy. So what I'm going to do is I'm going to reduce the workload for a second to let those go through. If you guys haven't seen my fancy pants tool, there's a JSON file that has all the workload defined, and you change the JSON, and then everything just adjusts to whatever's in the JSON.
Let me stop, and you can share it so you can show us.
So let's see. So you stop sharing for a second, so I can share, and I can just throw over my shell. So there's a directory that has these JSON files in it, and in here, if we just set the workload, so there's different types of workload that's in here, and we have the ability to change this to, be basically like a website workload, which is Internet Movie Database workload, just like select some very minor inserts. We can do reporting workloads, so analytics. We can also do comments, which is like a chat system, so that's heavier insert updates. We can also put long transactions if we want to see what the impact of somebody doing a select for update. That's what that does. And it holds a lock for somewhere between 1 and 5 seconds. And then we have read-only workload, and then we can do multi-row lists, and then we can also we have a special workload, which is if I want to stump experts, I can add things into the list of functions that I can throw things in there that will run under special workload. But just altering this file enables the workload to change.
Look at the
And
load on Aurora.
What was that?
Look at the load on Aurora.
All right, hold on. Let's see. So where are we? Oh, down to 12. Yeah. So we are pegged out here. So anyway, so I haven't made this change yet. So let me go ahead and I'll stop sharing, and let me go ahead and drop down some of this workload real quick. So let's drop that to 0. And so if I make changes to this file, this should go down pretty drastically or pretty quick. And so if you're watching at home, so let's watch. I just adjusted that file. I guess I can reshare my screen. We should see the workload take a pretty heavy dip there from an Aurora perspective. So I left the EC2 one alone. Let's see, that's not the right one. So let's look at this guy. Are those the same? Yes, they are. But so I want Aurora. So here we go. Let's see what we got here. Last 15 minutes. So queries per second obviously got dropped because of the alter. The number of connections. I'm guessing we're going to be backed up for a while because everything's going to be locked. Let's see what we got on.
How big is that table?
400,000 rows.
Okay.
I mean, the entire data set fits into memory. The entire data set. It's so tiny. Like it's less than a 10 gig total database.
Then it doesn't really make a difference. The double the memory that Aurora has, right?
Right. That's why it doesn't make any difference. That's why I didn't care. Aurora's kind of weird that way, where you can't like choose the exact same instance sizes. So we're starting to see a rebound here. And if I go look, did that finish? No, it's still running. And let's see, so yeah, so hopefully that will clear out. One of the interesting things when I set this up, here's a fun factoid. So Aurora allows you to take an EC2 instance and upgrade from or from a dump or from a backup or from another RDS instance to move to Aurora. But the latest RDS instance is 8026, and so I had an 8026 running. This Aurora is built on 8023. So you can't actually do a migration from RDS to Aurora because it has a mismatched version, which is a pain in the rear. Because I had this running with RDS before Aurora 8 came out. And so I wanted to do that upgrade, and I could not. So I was like, what? All right. So while that is running, did you see anything else, Marcos, that
browsing through PMM, and I can share my screen, but I haven't seen anything of that will give me much of a hint. Let me share it for a bit.
Okay.
Sure.
And we're back to Marcos's screen.
All right. So this is the Aurora movie instance. Last 3 hours. And
you should probably look at the last 30 minutes to 15 minutes, Marcus, for if you're comparing the recent changes.
no, yeah, well, here it comes. Look, now it's gonna do much more. Look, woohoo! It's taking more row writes.
Well, right now it's because it's building the index, right?
Oh, it's doing the index. Oh,
Yeah. So
No,
yeah.
No, I don't think that's the index. Rows deleted?
Maybe.
No.
Maybe.
Let's see. Rows read. It plummeted from 2 million to 500K. And let's see, MySQL instance summary.
All right, I'm just gonna, for the sake of time, I'm gonna force this to restart.
Here it is. Hey, I doubled your QPS, man.
Yay! All right, so that's because I just restarted the whole workload. So let's go ahead and run, and we'll run again.
Look, there you have your admin commands.
Yeah.
Hitting half the workload. No, but it's doing more work. Eh? I do think it's doing much more work.
Yeah, give it a second here. I gotta do. Let's see, I gotta reset the workload. Because we changed it. Now I gotta go back and.
Oh, you actually have changed it in the end. Oh, okay, I thought you were just showing.
Yeah, no, I actually did to see if I could just reduce it enough to get that through. So now I just need to go back and reset it to what I had it to before.
We have this out of that. All right.
523. 523. Two and 3.
So we don't have much in performance schema, I guess.
Okay, so now we should be starting back up now. And so we've got
so sharded exclusive logs appear to be hash table logs. Hash table?
so we do have the indexes now added on both, and the workload should be back to what it was a bit ago.
Come on.
But again, there's a minute delay, so it'll take a minute for PMM to start to show the QAN metrics.
Oh, come on. More than double.
Yeah. I mean, and so that was with just the one index. But again, if we compare that to, because we added it to both, if we compare that to the EC2 instance,
yeah, still far away. I get it.
Yeah. So I mean, there's something else that's weird with that particular workload.
There is something that is hash table logs and index tree read write logs, and those fell sharply after we added that index. So apparently Aurora is taking some synchronization logs. These are related to synchronization while doing the scans on a select. See what I mean?
Yeah.
I mean, this plummeted after we added the index, so they must have been related to that table scan, to that index scan. And while it was doing the index scan, it was holding sharded exclusive logs, apparently. Or well, no, rather, someone that wanted to acquire a sharded exclusive log had to wait behind those logs.
Which
right?
which could have been the alter table, right, to add the index.
No, because again, this is all the time. Look, this
That's
is
true.
worth of traffic.
Yeah, the index was. I mean,
The
we haven't been doing that for the last hour. Yeah.
Around here, right? Like you created the index here.
Yeah.
So again, what code is leading to this? I really need at least, Pullman profiler, a few samples of backtraces.
Yeah, but it's interesting. So just looking at Aurora right now versus the EC2, just that one index, tripled the queries per second. We're getting about 215 when we were getting around like 70 before.
Transaction purge latch, but this is so little that, I don't know. Because how Aurora, if you do very large reads on the secondary, you're actually blocking purging and creating history list on the primary.
Oh, really? Oh,
yeah.
Okay.
So that might also have something to do, right? Like those long reads are actually meddling with the undo, because they do have an open consistency view, and while they're running, even if they are not within a transaction, they do require. Did you have repeatable read here?
Default, whatever the default is, I don't know what it is.
It must. Can you go ahead and deploy read committed? Is that possible?
I could. I'd have to go redeploy code, but I mean that is something that I could try. We could follow up and see. But look at that difference. I mean, it's a huge difference just with the one index, which you want to properly tune, but still
I get that it was running fine before, like my beloved customer said. But I don't have the insight to actually give you a full answer.
But it is interesting to look at that and to see like some of the things that are turned off, right? So like when we were looking at the list of differences, there are things that are just disabled and not available as part of Aurora. And it's so interesting that I can get that same workload like throughput with certain queries, right? Like, so if I change the workload to be identical to like just a website workload, perfect. Like actually Aurora just shines, it's great. But when I start throwing in some ones that are a little bit hairy, like the query, where I'm saying like, hey, pick the top 50 movies for a given year. I mean, that's not that hairy, really. I mean, that's a common, like, they would think that that's pretty normal, right? So, Nando, you were going to say something. I cut you off as I was talking.
No. I was just curious because we were looking at the PMM and we were discussing that the AHI might have made a difference on EC2, right? And we could have our answer right there. We just had to check the graph.
You could disable. You could disable MySQL.
Yeah.
Disable. You have disabled on the Aurora, go ahead and disable on the MySQL to make a more fair comparison.
So add thread pools, try it, then go ahead and turn off
change buffer, adaptive hash index.
Adaptive hash index, and see if I can basically, instead of trying to get Aurora to match the MySQL instance, see if I can get the MySQL instance to match Aurora.
Yep.
Yeah, so the opposite way. Yeah, that's an interesting approach. Yeah,
it's but unfair, right? Because Aurora has its own optimizations that are done under the hood, and
this is true. And there are some things that it performs better.
Yeah, and that's what limits them to actually do all that MySQL is doing, right? So
Yeah.
Yeah, but
No,
the, the comparison is, I mean, the difference is very, very big. I wouldn't expect that much, Matt.
Well, and in this case, like you would need to double the box size in order to get the throughput that you need minimum. And I don't even know if that would work, which means doubling the cost, right? Like, I mean, you know, if this was your legitimate workload, you know, and, you know, you were, you know, running, your only option would be to upgrade.
Yeah.
You know, and it's interesting, you know, so, you know, as we're looking at these things, and I mean, I think this gets back to a theme that I'm kind of hitting on this year. I think that this is my New Year's resolution, everyone. Okay. My New Year's resolution is the small things matter immensely. And it's probably things you won't even think about. Right. You know, and in the case of like the Python thing that we were talking about earlier, right. You know, here I am running Python 3.10 versus 3.9.7. So it's, you know, like, that's a pretty minor upgrade. And there is that drastic of a performance difference. Same thing with, I decided to use the official Python MySQL connector. You know, again, these are things that there are so many components in our applications now, to test all the permutations is nearly impossible. And you probably have 4 or 5 of these things that seem very minor that are probably just destroying your systems and you aren't even aware of it.
Yeah.
You know,
yeah.
the look, the purge slash, it's killing the work. Is what actually kills the workload. Look.
Oh, here I'm going back to your shared screen. I'm
sorry.
Share. Yeah. Okay. So what are you looking at?
Oh no, I was looking at the wrong graph. I apologize. So
no. You made me turn you on for nothing. Like you made me turn on your screen for nothing.
I needed some attention. I spent 7 hours listening to someone else's voice. Come on.
Is that why you have no hair? You pulled out your hair during that session? Oh, God, I don't know what to do.
Yeah. No, you know, I thought that the purge slash, that I actually had a confirmation that it was affecting, but I don't see the impact on the MySQL questions now that I look back here. At first, I thought it was it was going down, but it was not going down so much.
Yeah, I mean, it has improved, right, with an index, which is great, which is what you'd expect. It hasn't improved to the point where it matches the other stuff. And like I said, if I mess around with the workload, I can get them to match. It's just I have to change the workload.
We still see these two, right? They are still there.
What are they? It's kind of fuzzy. I can't see what they are.
Say that again.
I can't see what those lines are. They're kind of fuzzy on my screen. I don't know if Nando
yeah. For me as well.
InnoDB hash table logs. Let me see if I can make that larger.
Yeah, it's just I think a bad connection, Marcos. So I think you're pixelated.
The definition of the display. Yeah, but
hash table logs and index tree read write log, which are synchronization primitives. I don't get it why we have a hash table logs. I need to look what that's protecting, and the index tree is obviously protecting the B tree. And this is on the undo, I mean. But yeah, I mean, these two were the ones that came down, and you know, we can observe that the throughput increased when those came down. So I would blame those and go to the source code and find out what they are about.
Right. Yeah. So interestingly enough, go ahead and from the Aurora instance, switch to EC2 real quick. Yeah. So just service name, go to the Meetup MySQL EC2. Go to those same graphs and see if those same locks appear there.
Okay, let me go here.
Yeah, let's see. I mean, if those are missing, or those aren't the ones that are popping up to the top, when you look here, it's handler, which is one of the popular
in Aurora. Client
But the
connection.
other one is not there. Yeah.
Slow
Yeah,
load.
the other ones aren't there. So those are new. Those are Amazon specific, I guess, right?
No. I don't think they're all.
No. Yeah.
Well, I mean, like that output,
Oh.
if you will.
Yeah. Exactly.
Having
Yeah,
the reaction to this workload is Amazon specific.
Yeah, that's what I meant. It's like that outcome appears there. I wonder if there's. Yeah, I don't know. It's very strange. But
Again, we are totally blind about what they're
oh
doing.
no, but this was actually really good to be able to go in and look at this stuff and see, like, what how you look, how you tune. But it also highlights, why some of these systems are so fragile when it comes to, the different database components and also the different application components and how they interact with one another. I mean, like I said, if I change the workload, and what I'm going to do is I'm actually going to run like 10 different workloads. I'll just let them run overnight. So I'll run like an hour of read only, an hour of, write only, an hour of this. And I'll just let them run overnight and see where the performance gaps are for each one of these. And maybe narrow down a little bit more even to what's bottlenecking. I think the bigger concern or the bigger problem that I see is I wonder if this does have something to do with the thread pool or something, just because the queries are the same. It's just they're getting blocked and they're getting stuck on some of those slower queries. They're still slow on EC2. They're just not getting blocked. So I'm wondering if it might be a thread pool thing. So I think I might try to disable the thread pool.
Again, instead of that, do the read committed first. I will go with read committed first because, again, there is this thing about how Aurora replicates through the redo log. But
would read committed still impact the read only workload, or like it shouldn't? If I flip it to read only.
No, right? Again, here we see that the read workload was, fiddling with synchronization primitives related to read-write logs.
Well, this workload that we have running right now is mixed. So there are writes and reads, so yeah, that's just the normal. Anyways, okay, fair enough. We have a couple things to try and see what happens. I hope everyone who's been watching enjoyed this. This was fun for me to dig into some of this. I don't know, Marcos and Nando, if you found this educational and exciting.
Absolutely. I love this Ask Me Anything sessions and, like having open conversations. Really, really like these meetups. And, I was going to tell you, in February, when I'm back from vacations, we should do those barbecues shows we have. I'm going to have my barbecue in good order. And so going to be able to set up a camera there and, we can have these conversations while also having some culinary conversations.
Yeah. So Juka, I don't think this has to do with a small buffer pool size, just because we've got a 20 gig buffer pool, and everything should be fitting into that buffer pool. I mean, like it's a 10 gig data set, so it's not huge. Maybe how many buffer pools did it have? Was it 4
instances?
Yeah, 4. Was it 4 instances? That still doesn't seem like. I mean, even so, with 20, that's 5 each. I mean, it's possible. I guess we could again.
You only have 4 cores, so it's kind of.
Yeah.
What else? I mean, again, I look at that. Everything else I look at through in InnoDB didn't tell me much, right? I tell much from the InnoDB metrics in PMM. So the one thing we did found was in performance schema. Hash table logs. There you go. Thank you, Guli Andoro.
Oh, Guli.
Yeah, but the only thing is that this workload, it shouldn't be reading from things outside the buffer pool. I mean, this workload's been running for like 12 hours. So
Hmm.
if it's not warmed by now,
Yeah,
there's another problem there, right? I mean, same thing with like, like it started at the exact same time as the other instance as well. So I mean, it's possible that it takes just longer to warm on Aurora. That's a possibility, I guess.
Hmm.
But I don't
Unlikely.
know. Yeah. Anyways, but thank you everyone for coming. We appreciate you hanging out. We appreciate the questions.
It was
What was
reading
that?
disk.
It was reading from disk.
Yeah, I guess I didn't even check here because it was like, man, you told me you have 20 gigabytes and that the database is less than 10 gigabytes. I just simply didn't look at that. You are misleading me.
It is. Well, if it's not warm by now, and I did a load from MySQL dump, and everything should be pre-warmed unless you're doing something really funky.
Well, read requests is. Oh, this is buffer pool reads, but wait, let me check buffer pool IO.
See, Marcos doesn't want us to go. He wants us to hang out all night.
Yeah.
I mean, Nando, it's dark where you are. You're like, I'm ready for bed. Like and Marcos is like, let's go another hour. Who's up for another hour? We all are, aren't we?
Totally into it, man. I'm totally into it. Page operations here. No. There's one too many dashboards, sections in this dashboard.
Yeah.
Yes. Yeah, that's interesting. No, yeah, it's zeros. So it's not reading from disk. I don't know why.
Yeah. So it should be like 100%. Yeah.
So I don't know why it's showing us that mutex.
Yeah. Unless it's trying to do something like funny behind the scenes to keep the cluster in sync.
Yeah,
but
it could be related to the way it replicates.
Yeah, I guess it's another option is I could create an Aurora instance without a replica. I don't know if that would make any difference.
It probably does.
So, all right.
It must wait for the other guy to say, I did got the piece of redo log, or well, it's sharing storage actually, right?
Yeah, I don't think that makes a difference.
No, yeah. Gotta try it. Anyway.
All right. Well, thank you, everyone. And we hope you appreciate, the bald Marcos and the rest of us trying to troubleshoot some interesting things. We hope you've learned some things. Obviously, we threw a couple curveballs out there. Some things, we're still not 100% sure why things are acting the way they are. But, we did have a pretty good call today. So thanks for hanging out. If you haven't subscribed to the channel, like us, reshare, tell people to watch the replay. Maybe we can get somebody from Amazon to come and tell us, what I did wrong and tell me that, you're just an idiot, Matt, you should do it this way. And I'll be like, cool, I can fix it, but it is something that is interesting to dig into some of these problems and see them real time. So
reach out to Alex Rubin. Have you had him in one of these episodes already?
We can ask him. We can have Mr. Rubin come and I could show him this and I could be like, Alex, fix it.
Yeah, go fix it.
But unfortunately, working for Amazon, I wonder if the Amazon guys have like a turbo button behind the scenes. Like, let me just log in here and hit turbo on that instance.
Now it's 33 megahertz.
Yes. But yeah. All right. Thanks, everybody.
Okay. Good night, everyone.
This was great. Yeah.
Have a good one, everybody. Bye-bye.